Okay, everybody, this is the recording of section 3.7. 3.7 is taking the derivative of different rates. Now, 3.7 is taking the derivative with respect to time. So far, we've only taken the derivative with respect to x or derivative with respect to y. Let's say I have this problem and we take the derivative with respect to x. So the derivative of y is y prime, and I just want to stress again, another way of writing y prime, these are the same thing, is the derivative of y with respect to x. These are the exact same thing, they just look different. You know, they have different symbology. And then using implicit differentiation, how do you spell implicit? Implicit differentiation. So you take the derivative here, 3 times 2 is 6, and then you subtract 1. Uh-oh, my pen. So if I bring the 2 down forward and then subtract 1, I get 6y. But since we're taking the derivative with respect to x, you end up with a y prime. And then this derivative is 8x x prime, but x prime, the derivative of x is 1. So we don't have to put the x prime because we're taking the derivative with respect to x. So if you're not familiar with this, go back and look at the implicit differentiation section. I think it was 3.5. So go back and look at that. If you haven't done it yet, then you're going to be a little bit confused today. So that's just implicit differentiations starting us out. So now we're going to do 3.7, which is using implicit differentiation, but we're going to take all of the derivatives with respect to time, because time is the factor that's changing here. All right, so let's start this. So find dy dt. Do you see? We want to find dy dt is another way of writing y prime, but it's y prime taking the derivative with respect to t. So the dy dt is y prime, but it's respect to time. So here's my problem. And in the last problem I showed you, we took the derivative with respect to x. So we didn't have to write x prime down. We didn't have to write it because x prime equals 1, right? If I have y equals x and the derivative of x is just 1, do you see? You don't have to write it down. But that's because we took the derivative with respect to x. Now we have this problem and we're taking the derivative with respect to t. So we're taking the derivative with respect to t. Since t is not the same letter as y, we take the derivative of y, which is y dt, dy dt, equals derivative of 2x, right? The derivative of y is 1, by the way, and then then the derivative of y. The derivative of x squared is 2x, but since x is not the same letter as t that we're taking the derivative, then you have to put dx dt, and the derivative of any constant is 0. So this is what it looks like. And I like to write it like this. 1 times, this is y prime, 2x, x prime. Do you see? Dx dt is x prime. Dy dt is y prime. So we have y prime equals 2x x prime. We took the derivative. Now look at all this. It says find dy dt. This is our problem. We took the derivative just like it told us to. Then it says plug 1 into x, 2 times 1. Plug 2 into dx dt. Dx dt is x prime. Plug 2 into there, and we'll find out what y prime equals. The answer to this problem is 4. So they're going to give us enough information to plug in and find the answer. Find y prime, dy dt over here. This is what we're supposed to do. The answer to y prime or dy dt equals 4. We're using implicit differentiation, and we're taking the derivative with respect to time. That means any other letter, x's, y's, or any other letter that we use has to have a prime with it. Take the derivative of that function and then put that variable prime next to it. Everybody okay with that so far? I'm hoping you did the implicit differentiation ahead of time, and if you didn't, you might not understand it all the way. Okay, Fabian's speaking for everybody. Okay. Let's see what's next. Where are we? Okay, so a pebble is dropped in a pond. Once again, when you drop a pebble in a pond, it creates these rings. Right? The rings are moving out. And so there's a radius on these rings. Circular ripples form when the radius of an outer circle increases at a rate. So we need to write some stuff down. The circle, the radius of the outer circle, we're talking about this outer circle, we drop a bond, you could have it there, but it ripples, and then the water, the ring moves out. So this is the outer circle right there. There's the radius to the outer circle, It's still moving, but there's the radius. So the radius of the outer circle increases at a rate of 1 foot per second. So you have to, and the hardest part about this problem is understanding what that means. The radius of the outer circle increases at a rate of 1 foot per second. Well, look, they want to know when R is 4. When R is 4, when we have 4 whatever inches, 4 feet, I'm not even sure what the units are. It doesn't matter to me because I'm doing the math. But the radius equals 4. That radius equals 4 on that outer circle. So it says the radius of the outer circle increases at a rate. In other words, the derivative is the slope. Remember, derivative is the slope. Another way we say slope is the change of rate. The change of rate in the past, if you remember, another way of saying slope is the change of rate. So it says increases at a rate of 1 foot per second. So the derivative of the radius, the change of rate of the radius when R is 4 is 1 foot per second. It gave us that in the information. That's the hardest part about this problem, being able to understand that R prime equals 1. Another way of writing R prime, I'm going to put it over here just so you see it both ways, dr dt. It's the derivative with respect to a certain amount of time. Dr dt is the same thing as R prime. So it says, what is the rate of change of circle's area? Well, here is the formula for area of a circle. I would write it down if you don't remember it, because you may have to use it. So we need to take the derivative. What is the rate of change for the circle's area? rate of change, once again, is the derivative. We're trying to find what A prime equals, the rate of change of the area. Okay, so it's a really easy problem, but you just have to understand what these things mean. So the area equals pi r squared. We're going to take the derivative. Take derivative with respect to time. In other words, we're going to find dA, the derivative of A, with respect to time. The derivative of A, by the way, the derivative of any variable, what's the derivative of X? If I take the derivative of X, can somebody tell me the derivative of X?
1.
1. What's the derivative of A?
A prime.
Yeah, it's 1 and then A prime. I just want to make sure everybody understands. It's just like a variable, like X. The derivative of X is 1. The derivative of A was 1. But since we're taking it with respect to time, T is not the same letter as A, so you have to put an A prime in there. The derivative of R squared is 2R. But since R is not a T, you also have to put an R prime. So this is the derivative. By the way, 1A prime is 1. 1 times A prime is 1. Good. So this is our problem. Our goal was to find A prime, so we just need to plug stuff in. 2 pi R prime. R, we already said, was 4. R prime was 1. And when I multiply this together, rate of change of area is 8 pi. That's it. Don't multiply it unless I tell you to. If it says round it to 2 decimal places or 4 decimal places, then you can. If I don't tell you to round it or anything like that, leave the exact answer, 8 pi. Does everybody see when we in this whole section, we're going to take everything with respect to time. You're using implicit differentiation. So that was the answer. The hardest part, once again, is being able to identify what it's saying. Any questions? You'll have these same type of problems in the homework. All right. Next problem. Air is being pumped in a spherical balloon. Oh, no. Oh, there. Oh, I was going to say, by the way, on the test, I don't give you this formula, and this is on the test. This exact problem, maybe the numbers are a little different, is on the test. So write down this formula. Somebody's going to say, I don't know the formula for the volume of a spherical balloon. There it is. I'm giving it to you now. Write it down, put it on your formula sheet. If you don't remember it, that's it. That's the formula for the volume of a balloon, a sphere. So air is being pumped in a balloon at a rate of 4.5 cubic feet. Find the rate of change of the radius. So I want to write down everything we do know. We do know R is going to equal 2. We already said that. Find the rate of change of the radius. So what are we looking for? In this problem, what will the answer? What's the answer going to be? Don't tell me the answer, but what letter or whatever are we looking for? What letter or symbol?
Slope.
Yeah, but what letter? I mean, at the bottom of my page, will it say X equals? Will it say Y equals? What am I trying to find in this problem?
V.
No, but that's a good guess. Find the rate of, see, this is what it's telling you what you need to find. Find the rate of change of the radius. So what are we looking for? The hardest part about these problems is interpreting them. The rate of change, we know radius is 2. We're trying to find r prime. Do you see? Rate of change is the derivative, the slope. Well, the slope of what? We're trying to find the slope of the radius. We're trying to find r prime, the derivative of r. Wrong problem. Okay, so this is what we are trying to find. I'm going to put a question mark here. Does everybody see that? In the problem, it says find the rate of change. That means find the derivative of the radius. Rate of change is the derivative, the slope, like somebody said. Find the derivative of the radius. R prime is what we're looking for. So in order to find r prime, I have to take the derivative, and I'm going to take the derivative of this with respect to t. So here's my problem. What's the derivative of v?
V prime.
It's 1 times v prime. I just want to make sure everybody understands. The derivative of v is like the derivative of x. The derivative of x equals 1. But since v is a different, because we're taking the derivative with respect to t, with respect to time, and none of these letters have t in them, so we're going to put the prime for each one of those, the derivative for each one of these. Then when I take the derivative of this, there's only one letter here, 3. So I bring the 3 out in front, times 4/3 pi, and then I subtract 1 r squared. This is the derivative. 1 times v1 is v1. By the way, the 3 on top and bottom cancel. Oh, but I messed something up. What did I mess up?
R prime.
Thank you. R prime has to go after the r. Okay, so this is what we have. We have to fill in the blanks. So the only thing we really need to know is, what is this? What does that represent? What does that 4.5 represent? What letter should I put here? Anybody know? Well, there's a hint. We only have 2 letters in this problem. Look at the formula. We have V and R. So there's 4 possibilities. There's 4. 4 possibilities that you could say. You could say R, you could say R prime, you could say V, you could say V prime. What does 4.5 represent? And somebody typed it into the chat box. Am I not seeing this right? It's 835. It's not R prime. Look at this. Air is being pumped in. R prime is what we're looking for, by the way. So I can't say 4.5 is R prime. That's the rate of change of the radius. This is air is being pumped into a balloon at a rate of 4.5 cubic feet per minute. That's V. Rate is a derivative. That's V prime. Do you see? This is volume, and this is the rate that is being pumped in, that the volume is increasing. That's V prime. 4.5 is V prime. The rate that the volume is getting bigger. It's getting bigger by 4.5 cubic feet per minute. Another minute passes, it gets 4.5 cubic feet more. Another minute passes, it's 4.5. That's the rate that the volume is increasing. That is V prime. 4.5 represents V prime. For those of you that are sleeping and not paying attention, I'm telling you, this class is very easy to fail. I'm just telling you. So we have everything we need. V prime equals 4.5. R is 2, right there. The only thing we need to do, like I said, it was find R prime. So I end up with 4.5 equals 8 pi R prime. If I divide both sides by 8 prime, I get 4.5 over 8 pi. 8 pi. Do you see? I'm dividing. This is R prime. We're multiplying it. So we divide both sides, and that's our answer. Do I want to put it in my calculator? No. I would leave it like that. Now, it's not necessarily correct because normally you don't put decimals in fractions. If you multiply the top and bottom both by 2, if you multiply this by 2 over 2, it would look like this, 9 over 16 pi. So either one is fine. But if it was a multiple choice test, I would think this would be the answer. Because you can't have decimals inside of a fraction, on the top or bottom. Does everybody get it? Does everybody understand? Do you see this? We're taking the derivative with respect to time. So whatever formula we use, we're going to take the derivative, and if t is not in the formula, you have to prime each one of those variables.
Is that 8p or 16p? 8 pi or 16 pi?
It's 8 pi on the bottom. I'm sorry, you're right. That pi should be on the bottom, 16 pi.
I mean, we have like 4.
You see, I multiply the top by 2 and I multiply the bottom by 2.
I mean, like on the formula, it says like v prime equals 4 pi r square r prime. So 4.5 equals to 4 pi times 2 square, right? The radius is r square, right?
Oh, thank you. Wait. Yes. Let's erase that. See, we made an error. Perfect. I like that. Somebody's paying attention. Thank you. I think this is what he's saying. We already said R was 2, and we said V prime was 4.5. Do you see we have 4.5 here? We have 4. We have pi R squared. So this is 4.5. What happened was I got messy. I didn't want to write down below, so I messed up. 4 times, this is 4. 4 times 4 is 16 pi R. That's what you're saying, right? And then now when I divide by, I take this over, 4.5 over 16 pi equals R prime. And if I multiply the top and bottom by 2, I get 9 over 32 pi. Is that what you meant? I hope. Whoever was speaking earlier. Yes? Everybody okay with that? What I didn't see is I didn't transfer over the 2 squared. You put a 2 in the R, 2 squared is 4. So 4 times 4 then was 16. That's how we got the 16 right here. So you can have this answer if they want a decimal and put it in your calculator, or this answer is more correct because you don't have a decimal in the fraction. Thank you. Any other questions, comments? All right. I'm glad you picked that up. And I think if I can get to the next page, we have one more problem. There we go. Whoop. I thought we were here. There we go. All right. So this, once again, this is it takes a little bit to interpret these to understand exactly what's happening. A plane is flying on a path leading directly over a tracking station. This is the tracking station. Here is the plane flying. It's the plane flying that way. The distance S is decreasing at a rate of, do you see right now it's the longest point. It's the hypotenuse of this triangle. That is a 90-degree angle. At some point, S, do you see it will be right here? This is S when the plane is directly over the tracking station. We want to know what happens when the plane's directly over the tracking station. So the distance is decreasing at a rate. The distance S is decreasing at a rate of 400. So what over here should I say is 400? This is important that you understand this. You should be able to tell me this within a second. What
S
do
prime.
S prime, thank you. Because we just said the distance S is decreasing at a rate. S is the distance, then when you take the rate of that S, that's S prime. That's the derivative of the distance. Okay, at 400 miles per hour. And it even says S is 10. So that gives us some more information. S is 10. And the distance from the tracking station down on the ground to the top is 6 miles. What is the speed of the plane? Okay, so we're trying to find the speed of the plane. What symbol do I use for the speed of the plane? That's kind of, oh, that's really important. You should be able to tell me that symbol now. Can anybody tell me the symbol I should use for the speed of the plane? Okay, so this takes us back to when we first did derivatives. We talked about derivatives. Can somebody tell me what this function is called? When I write a function that looks like this, what is this function called? Okay, what is this function called? What is this? Come on. What is this function called? There are three functions that we normally use. Tell me what any one of those functions is just called. Just tell me what they stand for. What does ST, VT, or AT represent? Anyone? Are you guys watching my videos? Are you taking notes? I'm just worried right now. Let's see if we have somebody typing. So I'm really worried. S is time. No, S is not time. T is the time. I already told you what S is, but no, you guys look right here. S is distance. This is called the distance function. This is where I'm trying to get to. That's called the distance function. Can somebody tell me what the next one's called? VT. There we go. Velocity function. Thank you, Paul. This is called the velocity function. And then we have acceleration function. By the way, the derivative of distance is velocity. You should know that. I mean, when we did the ball shooting out of a cannon problem in the past, the derivative of distance is velocity. Then when you take the derivative of velocity, it equals acceleration. So, I mean, that's how you should know this. So we already said this is the distance. S is the distance. So the question is, what is the speed of the plane? If velocity and speed go hand in hand, velocity is just speed with direction. So velocity and speed go hand in hand. So velocity is S prime. Do you see? It's the distance function prime. It's the derivative of the distance function. So what we're looking for, what were the distance S is decreasing. What is the speed of the plane? We're looking for the velocity of the plane. And if we look at X right here, it tells us, where does it say? It didn't even tell us what X is. X is the distance of the plane. X is the distance of plane. And X prime then is velocity of the plane. Do you see? X is the distance function for the plane, how far it is, and X prime is the speed of the plane. So what is the speed of the plane? We are looking for X prime in this problem. We are looking for X prime. This, right, the speed of the plane is X prime. So I need a formula that has X and S and the 6. Anybody know any formula with a triangle that looks like this? Any formula that we could use?
Pythagorean Theorem.
Yes, thank you very much. Remember Pythagorean Theorem, a squared plus b squared equals c squared. C is the hypotenuse. The hypotenuse is the s. So this is s squared. And then it doesn't matter. You can say a is 6, 6 squared. B is x, x squared. So this is the formula we are going to take the derivative of. Formula. This is the formula we're going to take the derivative of with respect to time. Take derivative. Uh-oh. I need to bring it back. There we go. Formula, take derivative with respect to time. So in this whole section, we're taking the derivative with respect to time over an amount of time. So by the way, this is 36. 6 squared is 36. So I'm going to take the derivative. 36 is 0. Derivative of a constant is 0. Somebody tell me what we get when we take the derivative of x squared.
2.
2 what?
X.
Keep going.
X prime.
Yes. So you see, because we're taking it with respect to time, so the derivative of x squared is 2x, x prime. The derivative of s squared is 2s, s prime. So this is our answer right here, the derivative. 2x, x prime equals 2s, s prime. We just have to plug stuff in. X, what was the question? It says S is 10 right here. So let's plug 10 in. S prime is what we're looking for. No, S prime is 400. Sorry. S prime is 400. X prime is what we're looking for, the velocity of the plane. Can somebody tell me what x equals? Anybody know what x equals? What do I put into here? Okay, everybody gets one guess. For the person who tells me the correct answer, types it into the chat box correctly, you get one guess. Oh, now you want to tell me the answer. I'm not going to look at the answers. Type in your answer. You didn't even let me finish. I was going to say 1,000,000 bonus points. The first person who gets the correct answer gets 4 bonus points. What number do I type in for x? Paul, I'm not going to tell you if you got it right or wrong. I want to see what other people type in. You only get one shot at it. I'm waiting. I don't think I see the correct. You guys are all over the place. What answer do I type in for x? 5 bonus points, 5 percentage points. If you get a 95, or I think 5 percentage points is worth 1 question on the test if there's 20. Anybody have a different answer? Anybody have a different answer? You only get one shot at it. By the way, just to let everybody out there know, nobody's got it right yet. What do I put down for x? Fabian, you don't get 2 guesses. And it's still not right.
That was a typo, sir.
That's okay. It wasn't right. Come on, somebody has to be able to give me the correct answer. 1. Good guess, Yvette, but it's wrong.
Because you said x was the distance of the plane, and then x prime is velocity of the plane.
Correct. I can. You have to be able to tell me what x equals. I don't see it in the work there though. I wonder what x equals. I'm gonna give 5 bonus points. I'll give you another 1 minute for the people who haven't tried it yet. Somebody should be able to come up with the right answer. How many people do I even have here today? I got 9 people here. Boy, we're missing quite a few. Uh-oh. How do you say your name? Adasalam? Somebody got it right. How did he get 4? Do you have a microphone? Do you want to tell everybody? Four is the correct answer. How did you get it?
I'm not exactly sure, but I was just like
Go ahead. What do you mean you're not exactly sure? Why did you type in 4? How did you get it? Tell me. Is your computer kicking in and out? Because we can't hear you. Well, he got the right answer, so I'm giving him the 5 bonus points, the 5 percentage points, which is equivalent to 1 question, 5 percentage points. So he did get it correct. Look, this is the problem right here. Let me do this up here. This is 6. We already said S was, what did we say S was? S was 10. Pythagorean theorem says a squared plus b squared equals c squared. So 6 squared plus b squared equals 10 squared. B squared equals 100 minus 36. Oh, wait. Somebody said 8. I got it wrong. I was going to say 4. Okay, so you were wrong. Sorry. The correct answer was 8. Let me go back. Who said 8 first? See, I picked on somebody and said they were wrong. Eric, is that how you got 8? For some reason, I thought it was 4 for some reason. But good, perfect. You take the square root of both sides and you get 8. Thank you. I was thinking it was a 4 in my head. I didn't do the work yet, but for some reason I'm an idiot. I look at 6 and then I'm thinking this: 6 squared plus 4 squared is 10 squared. No, it's not. It's 8. Pythagorean theorem. So yes, the correct answer is 8. Once I wrote it down, I realized that. So Eric were you the first one? Yes. Thank you. Eric, you should have been yelling at me when I told you got it wrong. You should have said, "No, wait a minute. I got it right." So Eric got it right. So remind me, Eric, after you take the test, I'll add that 5 percentage points, which is equivalent to 1 question. So do you see x equals 8 in that problem? Right here, at the time that we want, x equals 8. So we have 16x prime equals 8,000. 2 times 10 times 8, 400 is 8,000. So x prime equals 8,000 divided by 16 on my calculator. 8,000 divided by 16 is 500. And that sounds like a legitimate answer. 500, if you look at this, miles per hour. That's a decent speed for a plane. That's about what planes fly when they're traveling above our heads, about 500 miles an hour. So that is the answer to this problem. You had to use Pythagorean theorem to find that side. And you also had to use Pythagorean theorem and take the derivative to find the missing pieces. So it gave us everything except this, and we had to find this. Everything else was given to us. That was given. That was given. And this we had to use Pythagorean theorem. From up here. All right. That's it. That's all I had. Let me hit stop for recording.